Hello everyone. In this video, which is first part of the chapter 4 determinants, I'll be discussing about the definition of determinant and how to find the value of a determinant for a 2 by 2 and a 3 by 3 matrix. In the last chapter, we have studied matrices. A matrix is a rectangular arrangement of numbers or functions. So here in determinant corresponding to every square matrix, so to every square matrix A of order n, we can associate a number. That number can be either real number or complex number, which is called as the determinant of the square matrix A, where Aij is the ijth element of the matrix A. So the determinant, it is denoted by determinant of A or det A or delta. So for matrix A, this determinant of A, it is to be read as determinant of A. Even though it is written as modulus of A, it should not be read as modulus of A. It should be read as determinant of A. And another thing, only square matrices have determinants. Non-square matrix does not have determinant. So once again I repeat, for every square matrix there exists a number. That number can be either real or complex, and that number is known as the determinant of the square matrix. Remember that matrix was an arrangement of numbers, whereas determinant is a number corresponding to a square matrix. Now we'll start with determinant of a matrix of order 1, that is square matrix of order 1. So that is a matrix of order 1 by 1. So that means it will have only one element, that is, let A equal to matrix A. So this is the square matrix of order 1. Then determinant of A is defined to be equal to that one number, that is only one number is there, so that is the value of the determinant. So for example, suppose A equal to matrix 1, so this is a matrix of order 1 by 1 or a square matrix of order 1. Then determinant of A equal to 1. So since a matrix of order 1 has only one element, that element itself is the value of the determinant. Now to find the determinant of a matrix of order 2, order 2 means it is a square matrix of order 2, that is matrix of order 2 by 2. So let A equals to A11, A12, A21, A22, that is the general form of the 2 by 2 matrix A11, A12, A21, A22. Then the determinant of A is defined as, that is either denoted by det A or determinant of A or delta, is the product of the diagonal elements minus product of the non-diagonal elements. That is, first the product of diagonal elements to be taken, so A11 into A22, then minus the product of the non-diagonal elements. So value of the determinant for a 2 by 2 matrix is the product of the diagonal elements minus product of the non-diagonal elements. For example, the determinant of 2, 3, 4, 7, that is a 2 by 2 matrix. So the determinant of this 2, 3, 4, 7. So first the product of diagonal elements, that is 2 into 7, then minus product of the non-diagonal elements. So it is 2 into 7 minus 4 into 3, that is 14 minus 12. So it's equal to 2. One more example, A plus IB, C minus ID, C plus ID, A minus IB. So that means first find the product of diagonal elements, A plus IB into A minus IB, then minus the product of the non-diagonal elements. Here I is the complex number, that is I is the imaginary number, square root of minus 1. So A plus IB into A minus IB, so it will become A square minus I square b square. So I square is minus 1. So it will become a square plus b square minus c square. Again this will become plus d square. So minus of plus d square. So it will become minus d square. So that is a square plus b square minus c square minus d square. So for a 2 by 2 determinant, that is determinant of a 2 by 2 matrix, find the product of the diagonal elements minus product of the non-diagonal elements. Now we will move to the determinant of a matrix of order 3 by 3. So the determinant of a matrix of order 3 can be determined by expressing it in terms of second order determinant, that is determinant of order 2 by 2. So and it is known as expansion of determinant along a row or column. So to expand the determinant along a row or column, will be expanding using 2 by 2 determinant. So there are 6 ways of expanding a determinant of order 3. 6 ways of expanding a determinant of order 3 corresponding to each of the 3 rows. It can be using any one of the 3 rows, that is R1, R2 and R3, and any one of the 3 columns C1, C2 and C3, and each of these will give the same value. So a determinant of order 3 by 3 can be expanded using any one of the rows or any one of the columns. Okay, now let us try how to expand the determinant of a matrix, square matrix of order 3 by 3. So determinant of A is equals to, so I have taken it as A11, A12, A13, A21, A22, A23, A31, A32, A33. That is the standard form. So let us see how to expand it using first row. So similar methods can be followed for expanding along any other row or any other column. So first row the elements are A11, A12, A13. So in the first step, the multiply the first element of the first row, A11, that is first element of first row is A11 of the first row by minus 1 to the power 1 plus 1. Where does this 1 plus 1 comes from? 1 plus 1 is the sum of the suffixes of A11. Since we are taking the element A11, the sum of the suffixes, that is 1 plus 1 minus 1 to the power 1 plus 1 need to be multiplied with A11. So minus 1 to the power 1 plus 1 into A11. After that, delete the row and column in which A11 lies. Once you delete the row and column, that is here first row and first column, you will get a determinant of order 2 by 2, and with second order determinant obtained by deleting the first row and first column. Why we deleted first row and first column? Because first row and first column where A11 lies. A11 lies in first row and first column. Because of that, we deleted first row and first column. So after deleting first row and first column, we will get a determinant of order 2 by 2. So what we have to do, multiply the first element A11 of R1 by minus 1 to the power 1 plus 1. 1 plus 1 because it is the sum of the suffixes in A11, the position of the element, first row, first column. And with the second order determinant obtained by deleting the elements of first row and first column of the determinant A, as A11 lies in R1 and C1. So the first thing is minus 1 to the power 1 plus 1 A11, delete the first row and first column. The determinant obtained is a second order determinant A22, A23, A32, A33. Now after doing this, multiply the second element A12 of first row. That is, we are expanding along first row. So the second element of first row is A12. Again the same procedure, multiply A12 with minus 1 to the power 1 plus 2. where 1 plus 2, that is sum of suffixes in A12, and multiply with the second order determinant obtained by deleting the first row and second column. Because first row and second column, because A12 lies in first row and second column. So once you delete first row and second column, the determinant obtained is A21, A23, A31, A33. So that is the second part of the determinant of a 3 by 3 matrix, that is multiply the second element A12 of R1 by minus 1 to the power 1 plus 2. 1 plus 2 is the sum of suffixes in A12, and the second order determinant by deleting the elements of first row and second column, as A12 lies in R1 and C2. So that means it will become minus 1 to the power 1 plus 2 A12 multiplied with A21, A23, A31, A33. This is obtained by deleting first row and second column. So A21, A23, A31, A33. So in the third step, there is one more element in first row, that is A13 of R1. So multiply this with minus 1 to the power 1 plus 3, that is sum of the suffixes in A13, and the second order determinant obtained by deleting elements of first row and third column. So once you delete the first row and third column, the second order determinant obtained will be A21, A22, A31, A32. So that means the third element will be minus 1 to the power 1 plus 3 A13, then determinant A21, A22, A31, A32. Now first row has 3 elements, so we got all the 3 second order determinant. Now to expand the determinant of A, that is determinant A written as sum of all the 3 terms obtained in step 1. So 1, 2 and 3, so that is minus 1 to the power 1 plus 1 A11. This is by considering first element, this is considering second element, and this is considering third element. So minus 1 to the power 1 plus 1 A11, determinant A22, A23, A32, A33. So this is a second order determinant which can be expanded using product of diagonal element minus product of non-diagonal elements. So all these can be written in a single step. So determinant of A equal to A11. By expanding this, it will become A22, A33, A32, A23, and minus A12, A, then again expansion of the determinant A21, A33, product of diagonal minus product of non-diagonal. So this is the value of the determinant. So to expand a determinant of order 3 by 3 along first row, the determinant of A is equal to minus 1 to the power 1 plus 1. 1 plus 1 because A11, that is first row and first column. So A11, the sum of the suffixes. Then determinant obtained by deleting first row and first column. Then plus minus 1 to the power 1 plus 2 A12, the determinant obtained by deleting first row and second column. Then finally minus 1 to the power 1 plus 3 A13, the determinant obtained by deleting first row and third column. Now same way we can expand along any other row or any other column. For example, suppose we are expanding along second row. Second row, the elements are A21, A22, A23. So all the 3 steps are done in a single step here. So determinant of A is equals to minus 1 to the power 2 plus 1. 2 plus 1 because A21 is the sum of the suffixes is 2 and 1. Then the determinant obtained by deleting second row and first column. So that will be A12, A33, A32, A13, A12, A13, A32, A33, plus minus 1 to the power 2 plus 2, A22, A11, A13, A31, A33. That is the determinant obtained by deleting second row, second column. Similarly, second row and third column. Then expand that second order determinant, that is product of diagonal elements minus product of non-diagonal elements, and take the sign. So that will be the value of the determinant. So using any row or any column, the determinant can be expanded. but the value of the determinant will be unique. It's not like that you expand using any row or any column, you will get different values. The value of the determinant will always remain unique. So one more example, that is using first expansion along first column. So determinant of A is first column, the elements are A11, A21, A31. So again using the same procedure, minus 1 to the power 1 plus 1, because A11 is the sum of the suffixes. Then determinant obtained by first row, first column. Okay, first row, first column. So that is A22, A23, A32, A33. Plus then the second element of the first column, minus 1 to the power 2 plus 1, determinant of A12, A13, A32, A33. Then the third element of first column, minus 1 to the power 3 plus 1, A31, determinant obtained by deleting third row, first column. So that is A12, A13, A22, A23. So expanding along any row or any column, the value of the determinant will be same. So for easier calculation, we shall expand the determinant along that row or column which contains maximum number of zeros. So as per the definition, you can expand a 3 by 3 determinant using any row or any column. So you will be getting a unique value. But for easier calculation purpose, we shall always expand the determinant along that row or column which contains maximum number of zeros. And while expanding, instead of multiplying by minus 1 to the power I plus j, each element we have to multiply with the minus 1 to the power sum of the suffixes. We can multiply by plus 1 or minus 1 according as I plus j is even or odd. So suppose A is equals to a 3 by 3 matrix, A11, A12, A13. So A21, A22, A23, A31, A32, A33. So here the sum of the suffixes is even. So the first row, first column you are taking, it should be multiplied with plus 1. Then the second it is A12. So sum of the suffixes is odd number. So multiply with minus 1. So it will be like that, multiply with plus 1, minus 1, plus 1. Then alternate minus 1, plus 1, minus 1 for the second row. And third row will be plus 1, minus 1, plus 1 if you are using third row. So that means plus 1 into A31. Then the similar procedure, delete the row and column, take the second order determinant. So now let us consider an example, determinant of 3 minus 4, 5, 1, 1 minus 2, 2, 3, 1. So here it is expanded using first row. So first row, that is A11. So the first element, it should be multiplied with plus 1. So there is no change in the element. It is multiplied with plus 1. So that is first element is 3. Then delete the row and column in which 3 lies. That is first row and first column is deleted. Then you will get a 2 by 2 determinant, that is written here 1 minus 2, 3, 1. Then since the second element is minus 4, that is A12, the sum of the suffixes will be 1 plus 2, it is odd number. So that means it should be multiplied with minus 1, so minus of minus 4. And again the determinant obtained by deleting second column and first row and second column. So that will be 1 minus 2, 2, 1. And the final third element is 5. So A13, so that will be plus 1. So there is no change in the element. So it will be again deleting first row, third column. So the determinant will be 1, 1, 2, 3. So instead of writing minus 1 to the power 1 plus 1 minus 1, so as I told in the previous remark, it can be multiplied with plus 1, minus 1, plus 1. That means if the first element is, since we are taking first row, first column, the element is A11. So that means it should be multiplied with plus 1. The element should be multiplied with plus 1. Then the alternatively the sign will change. So first is multiplied with plus 1, second will be multiplied with minus 1, and third will be plus. And once you write it as a determinant of order 2 by 2, so it can be expanded easily. So by using the definition for a determinant of order 2 by 2. So expanding as a second order determinant, the answer will be 46 by expanding, that is sum product of the diagonal elements minus product of non-diagonal element. So you can verify that if you expand using any row or any column, the answer will be 46. So one more example, the determinant is 3 minus 1 minus 2, 0, 0 minus 1, 3 minus 5, 0. Now here, since the second row contains two zeros, it will be easy to expand along second row. So I am expanding along second row. So here it is written minus 0 because it is the second row, the first element is A12. The sum of the suffixes is 1 plus 2, that is odd number. So minus 1 to be multiplied. So minus 0, then minus 1 minus 2 minus 5 0, then plus 0, that is minus A22. So sum of the suffixes is even number, then minus of minus 1, this should be multiplied with minus 1. So minus of minus 1, so 3 minus 1, 3 minus 5. All these determinants are obtained by deleting the row and column, corresponding row and column. So this is minus, so first two you need not expand on them because it is multiplied with 0. So this 2 will become 0, minus 0 plus 0. The sign is important here, so it is because the A12, because it lies in second row, so it should start multiply with minus 1, then plus, then the minus of minus 1, that's why it is becoming plus 1. Then the value of the determinant, so 3 into minus 5 minus 3 into minus 1. So the answer will be minus 12. So we have expanded along second row because second row contains two zeros. So since it contains two zeros, it is not necessary to write these two determinants. These two determinants are not necessary. You can directly write the third only determinant which will be there. The first two will become 0. But the only thing is that you have to be careful about the sign here depending on the position. So since it is in second row, this element will be A23. So A23, that means it should be multiplied with minus, because the 2 plus 3 it will come as odd number. So these two are not necessary, you need not write this, you can directly write the single determinant. So that is the advantage of expanding along any row or column which contains maximum zeros. So here the advantage of expanding along second row is that for easier calculation purpose. Again, if you expand along any row or any column, the answer will be minus 12. So for expanding a 3 by 3 determinant, it is expanded using 2 by 2 determinant, and it can be expanded along any row or any column. So for easier calculation, you can take that row which contains maximum number of zeros. So that's all about the definition and of the determinant. Thanks for listening. I will continue with properties of determinant in the next video.